now we study product rule for the derivative. So if in example, if y is equal to u into v is given, where u and v are the function of x, so differentiating with respect to x, we get apply d by dx on both sides is equal to d by dx of u into v. So remember, for u consider the 1 and for the v consider the 2. So first go first, second go second, take the plus sign between them and take the derivative of remaining. So now here remaining term is v, so therefore we take the derivative of v, that is dv by dx. So now here absent term is u, so therefore we take the derivative, that is du by dx. So very simple to remember. How we remember? First go first, second go second, plus sign between them, then take the derivative of remaining, take the derivative of remaining. So we solve some example based on the product rule. So first example, y is equal to, very simple and important example, many times they ask x into e raised to x. So similarly we can apply the differentiating with respect to x, we get, so apply d by dx on both sides is equal to d by dx x into e raised to x is equal to, according to this property, so we directly write the solution. This is our first and this is our second. So first go first, second go second, take the plus sign between them and take the derivative of remaining. So now here remaining term is, that is e raised to x. Now here the remaining terms out of the 2, that is x, so we take the derivative of x. So what we get, so this is the as it is term, write down x, take the derivative of e raised to x, that is e raised to x, plus write down as it is e raised to x, and the derivative of x, that is 1. So what is our observation? Our observation, e raised to x is common, so we take, so what present inside the bracket? X plus 1. Okay, so in such way that we can solve the example based on the product rule. So let's we practice some more example for CET examination point of view. So we take y is equal to x into log of x, so we directly solve the example. So that is dy by dx is equal to, similarly remember, now this is our first and second, so first go first, second go second, take the plus sign between them and take the derivative of remaining. So now here remaining term is log of x, here the remaining term is x, so write down x as it is, then the derivative of log x, that is 1 upon x, plus log of x as it is, derivative of x, that is 1. So our observation, x get cancelled and now we get the final answer, that is 1 plus log of x. So next example, y is equal to, very simple, 3 raised to x into e raised to x. So we directly solve dy by dx again by using the property. So we remember the property, this is our first and second. So first go first, second go second, take the plus sign between them and the derivative of absent. So now here absent term is e raised to x, so we take derivative out of 2. Now here out of 2, so absent or remaining term is, that is 3 raised to x. So what is the answer? E raised to x, 3 raised to x as it is, derivative of e raised to x, that is e raised to x, plus e raised to x as it is, derivative of 3 raised to x, that is 3 raised to x into log of 3. So we get the answer. One more example we can solve, that is y is equal to a raised to x into e raised to x, again similar to like that. So very simple, so write down, now this is our first and second, many times the answer question is asked. So a raised to x, first go first, plus second go second, take the derivative of remaining term, that is absent term. So now here absent term is e raised to x, now here absent term is, that is a raised to x. So what is the answer? Write down a raised to x as it is, derivative of e raised to x, plus e raised to x as it is, derivative of a raised to x, that is a raised to x into log of a. So what is our observation? In both terms are same. So after taking the common, e raised to x into a raised to x, so what is present inside the bracket? 1 plus log of a. We solve some example directly. If y is equal to e raised to x into sine of x, so this is our first and second. So what is the answer? Dy by dx is equal to first ko first, second ko second, take the plus sign between them. What is the derivative of sine x? That is cos of x, we write directly, and the derivative of e raised to x, that is e raised to x. So next step, taking the e raised to x common, so we get cos of x plus sine of x, in such way that you can solve directly for CET examination point of view. Next example, e raised to x into tan of x. Very simple example. We make the first and second. So first ko first, second ko second, take the plus sign between them, and the remaining जो भी रहेगा उसका derivative. So tan का derivative sec square x, and the derivative of e raised to x, that is e raised to x. Again our observation, take e raised to x common, so remaining term into the bracket, that is tan of x plus sec square x. Next example, y is equal to x into sine inverse x. So again this is our first and second. So what is the derivative? First ko first, second ko second, that is sine inverse x. Take the plus sign between them. Derivative of sine inverse x, that is 1 upon under root of 1 minus x square, and the derivative of x, that is 1. So what we get? That is x divided by under root of 1 minus x square plus sine inverse x. So next example, y is equal to x into tan inverse x. So what is the derivative? That is dy by dx is equal to, now this is our first and second, mark. So first go first, second go second, take the plus sign between them. So what is the derivative of tan inverse x? That is 1 upon 1 plus x square, and the derivative of x, that is 1. So what we get? X divided by 1 plus x square plus tan inverse x. The next example is y is equal to sec of x into tan of x. So dy by dx is equal to, now this is first or second, right? First go first, second को second, plus sign between them. So derivative of tan x, जो भी absent है उसका derivative sec square x, and now here the derivative of sec x, that is sec x into tan x. So what is our observation? Our observation, taking the common, sec of x. So what is present inside the bracket? Sec square x plus tan square x. Next example, y is equal to 1 plus x square into tan inverse x. So dy by dx is equal to, make it first, second. So write down first ko first, second ko second, take the plus sign between them, and the derivative of tan inverse x, that is 1 upon 1 plus x square, and the derivative of 1 plus x square, 1 is the constant, derivative 0, and the derivative of x square, that is 2x. So what we get final step? So now here 1 plus x square, 1 plus x square get cancelled, so that is 1 plus, first write down 2x, then the trigonometric function, inverse trigonometric function, that is 2x into tan inverse x. So now this is the final answer. One more example we take, y is equal to x square plus 1 multiplication of x square minus x plus 1. So now we take the first and second, so dy by dx. First को first लिखना है, x square plus 1, write down second को second, x square minus x plus 1, take the plus sign between them. Now take the derivative of absent. So now your absent term is x square minus x plus 1. So what is the derivative? X square का derivative 2x minus x derivative that is 1 and the 1 derivative that is 0, that is constant term 0. Next multiplication, so derivative of absent, so x square plus 1 ka derivative 2 times x plus 0. So what we get final here, remaining terms 2x minus 1, so x square plus 1 into 2x minus 1, then x square minus x plus 1 into 2 times x. So we can multiply bracket expansion and we can solve further. If three functions are given, that is we take the one example for three functions of x into e raised to x into cos of x. So how we solve? Very simple. So dy by dx is equal to, write down the two terms as it is and take the derivative of next, that is x into e raised to x as it is. So we can take the derivative of third term, that is cos of x, plus for second make the x and cos x as it is, x into cos of x as it is, take the derivative of second term, that is e raised to x, and for the last write down the e raised to x and cos x as it is and take the derivative of first term, that is d by dx of x. So what we get final answer, so now x into e raised to x as it is, derivative of cos x that is minus sin x, very simple, plus x into cos x as it is, derivative of e raised to x that is e raised to x, plus e raised to x and cos x as it is, and the derivative of x is that is 1. So in such way that you can solve the derivative for the three functions of x. So let's we see in one more example, y equal to e raised to x into sin x multiplied by cos of x. So according to similarly, so two terms as it is, e raised to x into sin of x, take the derivative of third, what is the derivative of cos, that is minus sin x, we solve directly. In second, take two terms as it is, first and third, e raised to x cos of x, take the derivative of middle term sin x, so derivative of sin of x that is cos of x, plus kept constant second third as it is and take the derivative of first, so sin of x and cos of x as it is, and the derivative of third e raised to x that is e raised to x. So we solve directly in such way that you can practice many more example at your home.